Hi, I'm Dr. De Bruin, and this video is a walkthrough showing you how to answer this Hess's cycle exam question from the energetics topic of AQA A-level Chemistry. Before we get started, pause the video and have a go at answering this question yourself. I'd really recommend that it's worth getting your definitions for standard enthalpy changes on a flashcard and just memorising them, because almost every energetics question does include a 1-mark answer for one of these definitions, and so they're just easy marks to pick up because there's no understanding involved or application, it's just pure factual recall. So our definition for standard enthalpy change of formation is going to start off by saying it's the enthalpy change or the heat energy change. It's not enough to just say energy change, it needs to be either heat energy or enthalpy. And then because it's a standard enthalpy, we're talking about 1 mole of a compound being formed, and it's being formed from its constituent elements, in other words, the elements that make it up. And then the bit we need at the end is that all the reactants and all of the products are in their standard states. Don't be lazy and just say with everything in their standard states, because sometimes that's not worth the mark. Then our second part of the question is another sort of definition-y type bit. What is Hess's law? Well, Hess's law is this idea that the enthalpy change for a particular reaction is going to be independent of the route taken. So it doesn't matter how you get from the reactants to the products, the overall energy change will be the same, even if we've used a catalyst or employed a different route in between. The next part of the question is a straightforward 1-marker for writing an equation. So we start off with, do we actually know what the formula for butan-2-one is? And then it's obviously going to react with oxygen in order to produce water and carbon dioxide. And then that's going to need balancing. So we've got 8 hydrogens in total, so therefore we need 4 water molecules, and we've got 4 carbons, so we need 4 carbon dioxides, and then if we add up all of the oxygens, we will need 5.5 moles of oxygen for every 1 mole of butan-2-one. Now, at this stage, you would still get credit if you'd used multiples. So if you'd done as we would have done at GCSE and said, I've got 2 molecules of my initial starting compound, and then doubled up all of your other numbers. But it's important for the next part of the question that we understand that standard enthalpy of combustion is for combusting 1 mole. So even if in part 3 of this question you have written an equation with multiples, for the next part, in order to get the correct answer, we're going to need this as a single mole combusting. So the first thing that I'm going to do is to write this out again. I've obviously got it in the previous question, but I want to include it as part of my Hess's cycle. Now, in order to get the 3 marks for this question, you don't have to draw a Hess's cycle, but basically, if you get the wrong answer at the end, it's very easy to pick up a working mark for a Hess's cycle, but I don't think I've ever seen anybody get the working marks for an arithmetic equation, because if you get the answer wrong, it's going to be because your equation is wrong. So that's why I would really recommend drawing these cycles. Now, I've got some enthalpy changes of formation, so I'm going to need some elements. But we don't actually need to know what those elements are. You're not going to get any more credit for saying, oh, it's this many moles of carbon and this many moles of oxygen and things. So I would just save yourself some time and write elements in a box. And then we can start filling in some numbers. So oxygen is an element, and therefore its enthalpy change of formation is 0, so we don't need to include anything there. And then the next 3 we can fill in using the table, bearing in mind, of course, that we've got 4 moles of water and 4 moles of carbon dioxide. And then I'm trying to work out the enthalpy change for this reaction because it is a combustion reaction. So I'm literally going to write start and end on my exam paper to save me from accidentally going the wrong way around the cycle. And then I can't go along that arrow. I can't go left to right because I don't have that data. So instead, I'm going to go all the way around the long way, still going from start to end. So I'm going the wrong way up that -238 arrow, and therefore I need to include another negative, or I could change the sign, either would be fine. And then my other 2 arrows, I'm going the right way up, so I just add those in. And I get an overall energy change for this reaction of -2,490 kilojoules per mole. And it's right that it's a negative number because this is an exothermic process. And of course here we're combusting a fuel, so we would expect it to be highly exothermic. Thank you very much for watching, and if you are finding these walkthroughs of A-level chemistry exam questions useful as part of your revision, then don't forget to like and subscribe, and also let me know in the comments which topics you'd like me to cover next.